Good morning, students. So last class some problems discussion. So today we discuss about the topic is vectors. Okay. So today discuss about the topic is vectors. So what is the vectors and so what is the scalars and the total pattern today. So discuss. So now, so what is the physical quantities? So what is the physical quantities? So which a quantity is measurable, a quantities which have measurable, a quantities which have measurable is called as a physical quantities. Physical quantities. So just for example, velocity and time, displacement, distance. Okay. So number of are taken measurable. So is called as a physical quantities. Is called as a physical quantities. Okay, clear that. So now the physical quantities are mainly classified in three types. Okay, so physical quantities mainly classified in three types. Okay, so the first one is a vectors, and the second one is a scalar, and the third one is a tensors. Okay, so vectors and scalars and tensors. So what is the vectors? What is the scalars? What is the tangents? Now today discuss. And so the physical quantities are mainly classified in three ways. So first of all, one is vectors. What is the vectors? So what is the vectors is nothing but here. So vectors whose magnitude and direction. Okay, a vector whose magnitude and direction will have. So those vectors is those quantities is called as a vectors. Okay, so vector. Okay, so the taken in a vector. So having magnitude and direction, magnitude and direction. So is called as a vectors. Is called as a vectors. And so now another taken for example. So vectors. The displacement is a vector. Okay, so the displacement is a vector. So etc. Take a number of examples. And so what is the scalar? Scalar. A scalar quantity. Okay, a scalar quantity which have only magnitude but no direction. But no direction. So those quantities is called as a scalars. Okay, so those quantities is called as a scalars. So scalars is nothing but so mass is a scalar. Okay. Mass is a scalar, time is a scalar, okay, and momentum is a scalar. So number of etc. examples are taken. So what is the tensors? Okay. So next one. So and so vectors having so vector addition. Okay, that is to satisfy the vector addition. So what is the vector? So vectors having the magnitude and direction, and also satisfied or obey vector addition. Obey vector addition. So what is the vector addition? So now after some time discuss. So here taken what is the vectors? So vectors is nothing but so having the so that quantities having the magnitude and direction. Magnitude and direction also satisfied vector addition. Okay, vector addition. And so the next one is a scalar. So scalar is nothing but so scalar is a quantity. Okay, so those quantities having only magnitude but no direction. Only magnitude but no direction. Okay, so and so next one or example or note. So that is a physical quantity having magnitude and direction. Having magnitude and direction. So but no satisfy the vector addition. So just for example current electricity. Okay, now current electricity so having the magnitude and direction but no satisfied the vector addition. So that is a scalar. Okay, that is a scalar. Now more than examples are taken. So what is the tensors? So tensors is nothing but okay. So the tensors having the no direction and no displacement. So no magnitude and no direction. Any magnitude and so number of directions. Okay, na? So any one direction. So that type of the quantities is called as the tensors. So best examples of the tensors is stress. Okay, stress is also tensors. Moment of inertia also tensors. Okay, so moment of inertia and stress etc. taken tensors. That is nothing but number of magnitude. So number of directions. So that taken is called as a tensors. So what is the vectors? What is the scalars? And what is the tensors? The different direction, different magnitude. Different direction, different magnitude is called as the tensors. And what is the scalar? Scalar will have only magnitude but no direction. So that is called the scalars. Vectors having the magnitude and direction also obey the vector addition. Vector addition law. Okay, clear that? So vector addition law. So next one here. Next one. So taken that is. So here now vectors are classified in a number of ways. So first of all taken is the vector, unit vector, and second one is zero vector, and or null vector, and also third one is taken position vector, and so positive vectors and negative vectors, and negative vectors. Okay, so positive vectors. So positive vectors is nothing but here the taken. So one vector is taken A. So vector is represented by the arrow mark. Vector is represented by the arrow mark. Okay, arrow. So and also here taken A is the vector. And so and another vector is taken B also another vector. These two vectors having the same magnitude and traveling in the same direction. Okay, these two vectors having the same magnitude but no directions. So these vectors is called as a positive vectors. And so what is the negative vector? So negative vector is nothing but so a vectors having same magnitude. A vector having same magnitude but no direction, but opposite direction. Is called as a negative vectors. Okay. So what is the positive vector? So positive vectors is nothing but so here the taken having the two vectors. Okay, the two vectors having same magnitude, same direction. C is called as a positive vectors. And so what is the negative vector? So negative vectors is nothing but here the taken A and B are two vectors. So these two vectors having the same magnitude but in opposite direction. So is called as a negative vectors. And so now discuss the another vector is taken unit vector. Okay, unit vector. So what is the unit vector? And so whose the magnitude is 1 unit. Okay, whose the magnitude is 1 unit. A vector whose magnitude is 1 is called as a unit vector. So A be the unit vector. So unit vector is represented by the cap symbol. Okay, A be the unit vector. So A is equal and A by mod of A. Okay now. So and also we can write the A vector AXI plus AYJ plus AZK. Okay, AZK by AX square plus AY square plus AZ square. Okay, a vector A along. So A by vector A by mod of A. So AXI, AYJ, AZK by AX square, AY square, AZ square magnitude. Okay, so unit vector. So what is the unit vector? So magnitude is 1. Okay, magnitude is 1 unit is called as a unit vector, and so unit vector is represented by the cap symbol. Okay, so now discuss the another topic is zero vector. Zero vector. So zero vector or is also called as a null vector. Zero vector is also called as a null vector. So null vector. Okay, so null vector is represented by the O bar or 0 bar. Okay, and so zero vector whose the magnitude is 0. A vector whose the magnitude is 0 is called as a zero vector. Is called as a zero vector. Okay, is called as a zero vector. And so zero vector is represented by, and so unspecified direction. Okay, unspecified direction. Zero vector having unspecified direction. Okay, so zero vector is represented by, and so what is the zero vector? So zero vector is also called, okay, null vector, and so zero vector magnitude is 0. Magnitude is 0 is called as a zero vector. Is called as a zero vector. And so now taken another position vector. Okay, now another vector is position vector. So position vector is taken, okay, coordinate system. So x and y and z coordinate system is taken, and O be the origin. Okay, so now taken the one point is P. So P is join the origin. Okay, so OP that is called as a R. Okay, so I, J, K are unit vectors. Are unit vectors. Okay, if X, Y, Z coordinate system, and I, J, K are unit vectors. Okay, O be the origin. Now point P is taken in a space. Okay, so R be the position vector. Okay, R be the position vector, or R is equal, OP is also written. Okay, R is called as a position vector. So here taken, so O be the, that is the joining. So O be the origin of the coordinate system to the position of the particle. To the position of the particle is called as a position vector. Okay, origin of the coordinate system. Origin of the coordinate system to the position of the particle is called as a position vector. Is called as a position vector. Okay, clear that? Position vector. And so the position vector is represented, that is the OP is equal, or is equal xi plus yj plus zkij are unit vectors. Okay, so OP is called as a position vector. Okay, so represented by the, okay, coordinate system. So OP is equal, R is equal xi plus yj plus zk, and so magnitude of the R. So magnitude of the R, x square plus y square plus z square on the root. Okay, clear that? We have taken, so that is called as the point P. The point P is joined to the coordinate system. So that is nothing but here taken. So the position is represented, or with respect to coordinate system. With respect to coordinate system. Okay. So what is the position vectors, and what is the zero vectors? What is the null vectors? Okay. So and what is the unit vectors? So unit vectors is nothing but, so the magnitude, whose the magnitude, a vector whose the magnitude is 1 is called as a unit vector, and so the magnitude is 0 is called as a zero vector. And so position vector, so position vector is nothing but, so the position is that is nothing but the line is joining to the coordinate system to the point. Coordinate system to the point is called as a, the position is called as a position vector. So position vector is represented by the R, that is equal to OP, that is equal xi plus yj plus zk. Okay, clear that? So now taken another angles. Okay, in a vectors. So just for example taken. So a vector P or Q be the vector. Okay, is taken angle is theta. Angle is theta. So P vector tail is add to the tail of the Q vector. Okay, na? Q vector. PQ the two vectors. And so the theta will be the angle. And also, so here taken theta and here taken K, B and here taken P vector. Okay, P vector or A vector. Taken A vector. So the theta is the angle between and K is called as a positive. Okay, K is called as a taken positive. If in case of taken, so here taken minus KB and 180 minus theta and A vector and B vector and A vector and B vector. Here the K is called as a taken negative. Okay, K value is taken negative. And so collinear two vectors. So these two collinear two vectors and theta is taken 0. Okay, these two are traveling in the same direction. So the angle between these two vectors is taken 0. And so now also is taken in opposite direction. These two vectors are traveling in opposite direction. So the angle is made theta is equal 180 degrees. Okay, theta is equal 180 degrees. So here the taken, that is the some angles are so discussed in a vectors. So now another topic is taken. So now discuss the another topic. So that is the okay. So here taken two-dimensional system. So two-dimension. So resolution of the vector. Resolution of a vector. Okay, resolution of a vector into two dimension. Okay, so now here the taken so x-axis and y-axis, x-axis and y-axis. So R is taken is resultant vector. Okay, so here the taken extend some taken so 0. Okay, so the theta is making some angle. So that is nothing but R, x is equal R cos theta along x-axis and R, y is equal to R sin theta along y-axis. Okay, here the taken, so the vector is represented in a two-dimension. Okay, in a xy plane also. In xy plane. Okay, in xy plane. So R be the vector. Okay, is represented. How to represent that? In a xy plane. In a two-dimensional system. Okay, in a two-dimensional system. So now here the taken x-axis and these are two components first of all. Okay, these are two components, mutual perpendicular components. Mutual perpendicular components and along x-axis and y-axis and represented by the R in xy plane. XY plane. So now the projection of Rx, okay, is called as a horizontal component. Horizontal component. Okay, horizontal component. And the projection Rx is also called horizontal component. Okay, so horizontal component is Rx is equal R cos theta. Rx is equal R cos theta. And same pattern here also like that. So vertical component, that is vertical component is nothing but the projection along the y direction. Projection along the y direction is also called as a vertical component. So vertical component, that is called as a R y is equal R sin theta. Okay, so horizontal component or x is equal or cos theta. Okay, these are two components. And so magnitude of r, so magnitude of r is taken, that is r is equal under root of x square plus y square, under root of x square plus y square. Okay, so x square plus y square, under root of x square plus y square is the magnitude of the resultant vector r. So magnitude of the resultant vector r. And so direction. So the direction of the r with respect to x is, that is taken tan inverse. So tan inverse a y by a x is taken, that is called as the angle. Okay, so clear that? So that is the resolution of the vectors in a two-dimensional system or xy plane or xy plane taken. Okay, so next one is taken some study about some problems. Great. So now here see that a is equal, a vector a is equal I plus j. A vector a is equal I plus j. What is the angle between the vector and x-axis? So now here they taken a vector a. So making some angle theta with x-axis, So what is the angle? What is the angle? So represented in xy plane. So now write the general equation. A is equal, a vector a is equal axi a yj, axi plus a yj. So these are unit vectors axi a yj. So substitute comparing of these two vectors, so ax is equal 1 and so a y is equal also taken 1. Okay, ax is equal 1 and ay is equal 1. So we can write the x is equal 1 and ay is equal 1. So therefore tan theta is equal, so tan theta is equal ay by ax, that is equal 1 by 1, so it is equal 1. So the tan theta is equal 1, so theta is equal to 45 degrees. Okay, clear that? Theta is equal 45 degrees. So if taken the condition a is equal I plus a, what is the angle between the vector and x-axis? So here the taken is the a be the vector, so making angle with x-axis. Okay, so ax general formula axi and ayj. Ax is equal 1. Okay, right. So ay is equal 1. Okay, right. And so therefore the tan theta is equal ay by x, that is equal 1 by 1 and is equal 1. Tan theta is equal 1, theta is equal 45 degrees. Okay, clear that? So now another topic is taken. If this is called as a vector, if p is equal 2i plus 4j plus 14k and q is equal 4i plus 4j plus 10k, find the magnitude of p plus q. Find the magnitude of p plus q. So first of all, p plus q. So p plus q is equal 2i plus 4i, 6i. Okay, so 4j plus 4j, 8j and 14k, 10k plus 24k. Okay, clear that? And so the magnitude of p plus q is 6 square plus 8 square plus 24 square. Okay, so that is equal 676 and root is equal 26 units. Okay, so that is called as a magnitude of p plus q. So x square plus y square plus z square. Okay, 6 square plus 8 square plus 24 square, and simplification we get 6 under root of 676 is equal 26 units. Okay, clear that? So now today, so what is the vectors? Okay, what is the physical quantity? What is the vector? Physical quantity is classified in 3 types. So what is the vectors? Okay, so number of examples are taken in vectors. What is scalar? So what number of examples are taken? What is the tensors? Okay, tensors is nothing but no direction. So different direction, different magnitude. Okay, what is the vector? So vector having the magnitude and direction and having the vector addition also satisfied. And so so next to see మనకు scalar consideration. So what is scalar? So scalar is nothing but only magnitude but no direction. So next of all is taken. Okay, so next of all, so what is the null vector? And vectors are classified in the number of ways. So what is the positive vector? What is the null? What is the negative vector? What is the positive vector? And zero vector, null vector, position vector. Okay, so what is the positive vector? Positive vectors is nothing but these two vectors having the same direction, same magnitude is called as the positive vectors. What is the negative vectors? Both having the same magnitude but in opposite direction is called as the negative vectors. So zero magnitude is called as zero magnitude. Okay, so and 1 unit magnitude is called as a unity vectors are the taken. Okay, and so the next one is discuss the called as the resolution of the a vector in xy plane. Okay, so that is called as a horizontal component and vertical components are the taken, and what is the magnitude, and so the total find out. Okay, so the next one is the vector additions. So here the taken, what is the laws of vector addition? So vector addition is nothing but here the taken commutative law. So commutative law is nothing but a plus b is equal b plus a. So vector a plus b is equal b plus a. So that is the commutative law is obeyed. And so next one is associative law. So associative law is nothing but a plus b plus c is equal a plus b plus c. Okay, so now another taken is distributive law. So distributive law is nothing but so k of a plus b is equal ka plus kb. Here the k is taken scalar. So these are called as a law of vector addition. Okay, law of vector addition. So the commutative law is obeyed. A plus b is equal b plus a. And now is taken another associative law. So that is taken a plus b plus is equal a plus b plus c. And so now third one is taken distributive law is also obeyed. K of so the k of a plus b is equal ka plus kb. K is also called as a scalar. Okay, so next one. So next class lo study them so next some problems and so what is the unit vector, null vector and position vectors, and so a plus is equal a minus b. So many problems are studying in the next class. Okay, thank you student today.